We're going from the outside to the inside now. Yep, volume, space occupied inside a figure. Space occupied inside a polyhedron. Anybody else know what's going to change other than going from outside to inside? How do we always end an answer? You putting units on. Now the units are going to go from squared to cubic units. Yes, cubic. Before I start the prisms and cylinders today, I want to go over a little theorem here, which is called Cavalari's. That's the guy who invented it. Principle. Here's what it says. I got different examples up here. If you get two solids, they both have the same heights. All right, they both have the same heights. And when you take a cross section, the cross sections have the same area. They're going to have the same volumes no matter what they look like. All right, does everyone see here? Kind of leaning, really leaning, straight up and down. All three have the same volumes. Then I go pizza boxes or whatever it is. I stack them straight up and down. This volume is going to be the same as if I just tipped them over to one side or if I just really scrambled them up. Why? The heights don't change. And if I took a cross section and found the area of that cross section, it's always going to be the same. So the volumes of all three, believe it or not, are all the same. Classic example, coins. Coins. All right. These two sets of coins have the same volume because their heights don't change. And if I took a cross section, that area would be the same. So I got out my good old buddy GeoGebra here to show you guys that they don't change. All right. These look pretty much totally different, right? But the heights are all the same. All right. And they're showing you, everyone see how if I took a cross section of each, they're a totally different figure, but all their areas are the same. 16, 16, 16, and their volumes are all the same as well. As long as they have the same height and same cross-sectional area, watch. Those figures look three totally different figures, but they all have the same volume. Okay, all have the same volume. All right, no matter what I change the height to, those volumes are all going to be the same. Okay, same height, same cross-sectional area. Volumes will always be the same. All right, so that's Cavalari's principle. And why am I harping on this so much? Because I never did harp on it so much, and then it came up on the Regents exam last year. And kids were like, we never went over Cavalari's principle. We did. All right, it was 2 minutes of a day in May, so all right, it is on there. All right, volume of a prism. Sorry if I'm interrupting other classes' work for some of you. I don't know what I was thinking. Yep. You guys got formula sheet on you? If you don't like the way it is, just don't come to class. Pretty simple. Everyone have a formula sheet? If not, I got some extras here. And don't complain about grades. We're going to start using these more than we ever had before because you will notice most of the volume formulas are on there. All right, so make sure you guys hold on to these, please. Everyone see volume, general prisms. Everyone see those on there? Everyone see that formula on here? General prisms, volume equals BH. Let's talk about what each piece means. Let's start with H. That's going to be height of the prism. And anybody want to try to describe to me what I mean by a height of a prism? That's the distance from the bases. Identify what the bases are. The distance from each base is the height. And now we got to talk about big B. All right, and there's a reason it's capital B. That's the area of a base. Okay, that's the area of the base. So whatever the base is, we're going to find the area, that's big B. Not both bases, just a base. All right, that's big B. Going through these three prisms right here, can you identify what shape the base is in for me? So this first prism here, what shape is the base? This is a rectangular base, yep. I just want to make sure we can identify where the base is. How about the next one? Ooh, no, not for a prism. Just because it's on the bottom doesn't mean it's the base. Remember what the bases are, the two figures that are congruent and parallel. So here it would be triangular base. And what about this figure here? Hexagonal base, yep. So when we find the volume, you're going to find the volume of the rectangle, find the volume of one triangle, find the volume of one of the hexagons. Cylinder. And I'm not going to play around with these because they're on the darn formula sheet. Okay, so I'm not going to be tricky about this. It is B. You can still consider it BH because it's a prism. What's the area of the base? What's the shape is the base? Circle. Area of a circle. And this is what's on your formula sheet. Pi r squared is the base times the height. It's on your formula sheet, though, so I'm not going to harp on it. All right, let's find the volume of each. BH. Here we go. First of all, what shape is the base? Here we go. What shape's the base? 16. What shape is the base? It is a right triangle, correct. So how do I find the area of one of those right triangles right now? Here we go. 7. How do I find the area of that right triangle? Which would be what in this case? 1/2? 15 times 8. Everyone, that's big B right there. In the brackets right now is big B. Now, hey, when I say height, that's not height of that triangle. It's the height of the prism. The distance from each triangle right now. The height of the prism. Not the height of one of the triangles, the height of the prism, which in this case, what are we looking at? 11? 8, yes. Look, everyone see? The distance from one base to the other right here is 8. There it is. And somebody mentioned it already, 480 meters cubed now when we got volume, cubic units. All right, ready? Next one. Identify the base first. What shape is the base in this one? 18. What shape's the base? Triangle. All right, so it's going to be 1/2. No matter which side I pick as the base, it's going to be 3. How are we going to find the height, though? How can I, again, not 9. I'm not looking at 9 here. I'm looking at the height of that triangle. Thoughts on how I can find the height? 3, 3. Anybody know this edge? 3. All right, because they match. All right, so I got 3, 3, 3. So if I try to draw that out right now, 3, 3, 3, trying to find the height. Will, thoughts? Okay, so we're moving. Anybody? I'll put a 60 there. Okay, I can put a 30 up top. I know it's a 30-60, but where do I go from here? Mike?
Do you divide the base side?
As long as it's equilateral isosceles, the altitude also is a bisector, so that is 1.5. Yep, nice job. All right, how do I get to the height then? It is across from the 60. Across from the 30 is 1.5, so across from the 60 is got to be 1.5. Radical 3. And multiply it by the height of the prism. Height of the prism. What's the distance between the two triangles? 9, yep. So times 9. And no rounding directions here, so we know the deal. Regents level now. Write them all out. When you're ready, 2, when you're ready. Yep, you're good. What do we got? Cubic feet? Yep, Emily, go.
Why don't you want to find the area of both?
Because remember, the big B just stands for area of A base. That's what capital B is, area of A base, not both bases. Okay? Yep, just for surface area. Cylinders. Do me a favor, just so we don't have to write out all these numbers, leave it in terms of pi for me for these 2 cylinders. All right, leave it in terms of pi. Okay, let's get right to it. Here we go, 10, right off the formula sheet. What was the volume again of a cylinder? Pi r squared times the height. Thank you very much. Pi, how about the radius for this cylinder? Radius for this cylinder. 5? 5.5. How'd you get it? There you go, 5.5 squared. And according to this diagram, what's the height? Here you go, 5 again. What's the height? 16. Leave it in terms of pi for me. Leave it in terms of pi. Leave the pi in the answer for me. In terms of pi, here you go, 7 in terms of pi. Got it. And then same thing here, pi r squared times the height. I'm not going to ask anybody on this one. You got your radius of 3, height of 6, and 54 pi. Look good? On your own or in your group, volume of 5. Hexagonal prism now, volume of 5. Big B, so find the area of that hexagonal base times the height of the prism. Go ahead. Got to do a little work. If you're a 1/2 AP person, fine. If you're breaking it up into triangles, go ahead. Find the area of the base. What's the, most of you guys are probably using 1/2 AP. What's the perimeter of that base? Here you go, 12 perimeter of that base. What is it? 36, yep. And Emma, did you find the apothem length? 3 radical 3, yep. And then 8 is the height of the prism. 8's the height of the prism. And I'm getting out 748.2459489 cubic inches when I multiply everything through. You're okay? How do you feel on the volume here, prisms and cylinders? Cylinder, no issues because the formula's right there. Pyramid, prism depends on the base, I guess. Depends on the shape of the base. All right, last thing we just got to cover is these solids here that we've been working surface area with. I got good news though. Remember surface area, you always have to worry about what? Finding the surface area of one of these. Yeah, I don't think I have it up here. Yeah, this is the first one we did today. Finding the surface area of one of these, you always have to worry about what? What the heck's covered up. But if I'm doing volume and I'm going inside, do you think I have to care one bit about what's covered up? Nothing. I do not have to care one bit about what's covered up when I find volume because I'm just filling up the figure on the inside. So what the heck do I do? I don't have a volume of an L. I got a volume of prisms and cylinders, but I don't have a volume of an L. Will? Sure. Where do you suggest I draw a line to split it up? Because there's a couple lines I could draw here. So right here? Horizontal? Okay. So I split it up. Looks like Will split it up for us into 2 prisms. I'll just call it prism number 1 and prism number 2 down here. And could we have also just drawn a vertical line down? Fine. Could we have drawn both in? Yeah, sure. Now you're finding 3 prisms now. All right, we are going nuts. All right, so if we did it this way, for me anyway, the volume of number 1, still BH. Let's see, what would my base be here? 4 by 2, it looks like. And what would be the height here? Because that's 8 right there. That whole thing is 8. That would have been, let's see, that's 3. So this is the height. That's what I was thinking. 5. Everyone see where I'm getting that height of 5? Base 4 by 2. 4 by 2 times the height, not 8. The whole thing's 8. I had to subtract 3 from it to get 5. So the volume of that first 140. What about the volume of the second one now? Base 2 by 6. And what's the height of that one? 3. 76. Nope, that's the total. How about we go 36? So the total volume, that's 76 cubic feet. Just change one measurement on 7 because we're going to get 2 different answers from people if we all keep this the same. Can you make this 12 inches, 8 inches, please? All right, 8 inches. Because that's big for the circle over there. All right, what's this made up of? Ooh, what's a square? Square is 2-dimensional. This is a prism, right? Rectangular prism. And what's the other portion of it? Half cylinder, yep. And we're finding volume. If you want to talk it out with your group, go right ahead. If you'd like to try it on your own, go ahead. And we're rounding to the nearest whole number from the directions.
What did you get for the Hexagonal? 150. Why did you have 2 6s? How much do we need?
Okay, I'm actually seeing a lot of different answers here, so let's try to clean this up. The prism. All right, start with the prism. The base. All right, somebody asked a good question. Well, how can you tell what the base is? And I'll be honest with everyone, it doesn't matter. I could pick this bottom 11 by 6 as the base, then my height would be 8. I could pick this right here, this 6 by 8, but then my height would be 11. Why am I saying it doesn't matter? You're going to end up multiplying all three of them no matter what you pick as the base. All right, so for this prism, 11 times 6 times 8. You probably heard back in middle school, length times width times height. Remember that old one? That's for our prism, rectangular prism. Yep. So this one turns out to be 528. Okay, so let's go to the half cylinder. So 1/2 pi r squared times the height. Here's where I was nervous for the radius. What is this right here? That's the diameter, right? And what's the measure of that? It's 8, right? So what's your radius? 4. Now let's say you didn't take it that way. Notice I gave you 15 here, right? So from here to here would be your radius. And how long is that distance? 4. 11 minus 15. That's why I had to have you guys change that. 4 squared. Ooh, ready? Height of the cylinder. I can't stress this enough. Circular base to circular base. Here's one circular base. On the opposite side's the other one. What is the distance between them? It's going to be 6, yes. Okay, the distance between the bases is 6. And I'm not too sure what that I had 48 pi for that one. that right? That's 16, that's 8. 8 times 6 is 48. Yep, 48 pi. So now add them together. The total volume, 48 pi plus 528, rounded to the nearest whole number. I have 679 cubic inches. We okay there? Okay, you have two choices right now. You can start on the homework that's due Thursday, or you can start looking through all the surface area formulas for tomorrow, cross-section stuff, or faces, edges, vertices. All right, it's up to you, but it's one of those two. All right, there's no other option. Still got 5 minutes here and 5 problems for due Thursday.